Hi everyone, my name is Kumar Venkateswar, and I'm delighted to be here to talk about Amazon SageMaker. I'm joined here by Monica from Intuit, who will join me later in this presentation to talk about Intuit's experiences working with SageMaker early on. So to start with, I'd like to kind of look at why we built Amazon SageMaker and why I think this is an important product at this time for AWS. Next, I want to talk about what SageMaker actually is, what are the components to it, how it's put together, how it's architected, and kind of move into how you can get started with SageMaker and how you can get started using it for applications today. And then Monica will talk about Intuit's experience using Amazon SageMaker, and then we'll hopefully have a little time for Q&A after that. So why did we build Amazon SageMaker? One of the things that we've seen over the past few years is that we continue to see this trend in computing that developers are involved with many aspects of the application. You look at front end and UX, and that's been important for several years. Mobile has maybe been important for about a decade now. Back end and operations, of course, is super important. But in the last 10 years, we've seen that data and analytics have become a very important part of the developer's tool set. And developers work together with data science and data engineering teams in order to drive the kind of personalized experiences and smart applications that customers expect and that we all expect as consumers. So as part of that, AWS has thought of this as grouped into 3 different types of data-driven development, where we have products that are focused on retrospective use of data, and you have excellent products like Redshift and RDS. There are some products that are focused around here and now processing of data, like Kinesis, for instance. And then you have this third set of platform products around inferences and using this data in order to come to logical conclusions that you can actually use in your products to make them much better. So what are the barriers that people see with respect to using these inferences in their products today? The biggest thing is machine learning process in general is pretty hard. You start out with data. The data is very frequently not particularly clean. You see things like text input data where it's not normalized. You'll see people type in things like US, USA, United States of America, and that kind of thing is all essentially equivalent from an information perspective, but when you look at the data, it's pretty dirty. The second challenge that people actually encounter is that putting together those data sources and consolidating them into a single repository or a single place where they can further process it is particularly difficult. And then, in addition to that, you see that setting up an infrastructure that can be used in order to process this data, understand the data, and figure out what value you can extract from the data, all of this is a challenge. If you look at the next stage, so assuming that you have a clean set of data, the data scientist or a developer has a good idea of the kind of question they want to ask, how the data can be used to answer that question. The next thing is to experiment with it to try and figure out the right way to get a model that answers that question in an accurate fashion, or an accurate enough fashion to meet business goals. But at that point, you say, well, how do I set up and manage these distributed clusters in order to do it? And that's frequently an issue because every time you want to spin up a cluster and spin it down, most of our customers right now just kind of leave those things up and running, and you end up with compute clusters that are idle some percentage of the time, it's not particularly ideal. And in addition, scaling up and creating these distributed ML algorithms that can work on truly big data sets, data sets that go to terabytes to petabytes, is really, really difficult. So let's assume you get through all of that, and then you're now ready to deploy it into a production environment so that you can put data in, get the inferences out, and get the kind of value that you want to get from this data. The next thing you have to do is now you have to set up another set of clusters, another set of inference clusters. You have to manage and auto-scale the inference APIs so you can consume them. It's a pretty heavy lifting process to test them, version, monitoring, all of that is super heavy lifting. And in some ways, this is actually the most difficult part, because there's usually also an organizational boundary that you end up crossing in order to get to this point. For instance, one customer that I talked to early on in our thinking about SageMaker was telling me that once they actually generate a model using R, they have an offshore team that takes that R model, translates it into Java in order to put it into production, which I heard that and I was like, that's amazing and crazy that you would actually have to have an offshore team do that. And then at the end of it, you actually don't know whether they did it accurately or not. So the R model could have been really, really excellent at working on historical data, but once it gets into production, you have no idea whether that representation actually represents what the model that the data scientist worked on. So at the end of it, 6 to 18 months goes by. 18 months is probably an outlier, and it's the company with the offshore team. But saying that it takes about 6 months in order to go from an idea, hey, I have an idea for some way that I can improve the product that I'm producing with data, and getting it into production, even 6 months is just way too much. I was talking to one customer yesterday, and he was telling me they think 2 weeks is too slow in their industry. They want to get models out in a matter of hours. So in order to do that, we really feel like it is our responsibility to come up with products that enable our customers to do that. Machine learning in general is an enabling technology that has so much potential across so many different applications. It's capable of answering these little questions, and as you build up your muscle and build up the capability to answer these questions, it produces some really, really amazing results. And honestly, we're in a great position to provide that kind of product to you, and we feel a responsibility as AWS to provide a product that lets you take the data that you have stored in AWS, use the compute that we provide in order to really transform your business. So how do we do this? Our goal with Amazon SageMaker is to actually enable you to do this. Amazon SageMaker is the quickest and easiest way that we could come up with for you to get ML models into production. That's our goal. So how do we go about doing this? First of all, it's an end-to-end machine learning platform. So we provide a way that you can have managed notebooks. We provide a way that you can do the experimentation, and we provide a way that you can deploy into production. And the goal with this is zero setup. If you noticed how many times I said, well, you set up the notebooks, and you set up the clusters for training, and you set up the clusters for inference, I feel like I said that way, way too many times through this process. And I feel like customers really don't want to do this setup. It doesn't make any sense. So the goal here was to provide zero setup environments that allow you to get started quickly. The third thing is, we got a lot of feedback in some of our previous products that customers really wanted us to be flexible. And we want to be where you guys are. If you guys want to use TensorFlow, that's great. We want to be there so that you can use TensorFlow better. If you want to use MXNet, same thing. If you want to use Gluon, same thing. We want to make sure that you have the ability to make the business decisions to use the products that you need to, and we'll provide the platform that allows you to use that very effectively. And of course, last but not least, you want pay as you go. You don't want to pay for things that you're not using. You want to pay for it when you're using it and not when you're not. So we're providing pay by the second in machine learning. So the first part of it, and I think one of the most exciting parts, is distributed training that works with you. So we have an environment that with a single API call, and I'll demo that later on, allows you to spin up a cluster and do distributed training on massive amounts of data. The first way that you can utilize this distributed training environment is through a set of Amazon optimized algorithms through the AWS SDK. So we have a set of 10, 11, something like that algorithms, depending on how you count. And you can use those through the SDK very easily with one API call. The second way that you can use them is that you can use them through Apache Spark. So a lot of customers use Apache Spark for data processing. It's a great environment for data processing. It's not a great environment for ML in certain cases. So because of that, you can actually use an Amazon SageMaker provided library in order to call Amazon SageMaker from Spark and allow you to use those capabilities in your Spark environment. The third thing that you can do is you can bring your own deep learning script. So supposing the algorithms that we provide are not sophisticated enough for your data scientists or your data science skills, and you want to use deep learning. You can also bring your own deep learning script, and you can submit that deep learning script to SageMaker, and we will spin up a cluster. We'll do the distributed training, whether it's TensorFlow or MXNet. We'll do the distributed training. We'll set up the parameter servers, set up the workers, everything, and bring you back the results. And the fourth thing is, for the truly sophisticated customers that have hand-coded their machine learning algorithms, we still wanted to be able to help you. So the fourth thing you can do is bring your custom Docker image, and we will still consume that Docker image and use that for distributed training. So the first thing I talked about was these algorithms that are designed for huge data sets. We designed them with the goal of terabyte to petabyte scale data sets. And when you look at these types of large data sets, one of the things that you can't do is load the entire thing into memory. That's not really an option. It's also a challenge to move data back and forth. It takes time. If you move data from one place to another and then end up processing it, you end up spending most of your time pushing data from one place to another. And in order to avoid that, our algorithms consume streaming data sets, which means that you don't have these essentially idle clusters waiting for data to come. You stream the data and process them as they come in. The second thing that we did with our algorithms is we made it so that they had single pass training. So the data streams over, and then we process it, and we never have to go back in the stream in the process of generating that machine learning model. The third thing that we found is that open source algorithms, for the most part, are not developed with the idea of large data sets with great reliability. One of the challenges with these is that if you if you look at non-commercial environments, there's a somewhat larger tolerance for being able to run it over and over. And we know that AWS customers, whether commercial or non-commercial, are a very demanding set of customers and want us to produce something that's truly reliable. And in order to do that, our algorithms have great reliability on large data sets. The fourth thing is that we wanted to make sure that we had a pretty good array of ML algorithms so that you could get started up and running quickly, no matter what your problem is. So what do we have? We have this set of algorithms. We have gradient boosted trees, factorization machines, and linear algorithms for classification and regression problems. We have k-means and principal component analysis for clustering and dimensionality reduction. We have an image classification algorithm, which is a convolutional neural net that's built in, as well as we have LDA and a neural topic modeling model for topic modeling, as well as sequence to sequence. So you have this fairly broad array that you can use to get up and running very quickly, even if you aren't particularly sophisticated in terms of your data science depth. Next, well, let's assume you have your model. Now, the next challenge is to get into production. So in order to help that along, we have one-step deployment. We'll bring up the cluster, deploy the model to it, and we'll host that model behind a REST endpoint so you can easily consume it in your applications. The hosted environment provides low latency, high throughput, high reliability hosting so that you can be confident that you can use it. We also have built-in A/B testing. So one of the very, very common things that people do with machine learning models is they say, well, yeah, that worked well on historical data, but what happens when I put it into production? Is it going to work the same way? One of the ways that people do this is they do A/B testing at the application level. And A/B testing at the application level is great, but you don't necessarily need the heavyweight process of A/B testing at the application level if all you're changing is a few hyperparameters within your machine learning training. You can just deploy the model. It hasn't really changed very much, and as long as you can deploy them side by side and test out to see whether your improvements prove out in practice, it's a really, really powerful idea. So we've included A/B testing as part of our hosting environment. The other nuance to that, and this is one of my favorites, if you haven't started with machine learning algorithms, there's no particular reason that you can't just Dockerize your business logic and compare that against a machine learning algorithm. We accept Dockers. You can bring your own model the same way that you can bring your own training algorithm. And if you end up using a Docker container to compare your business logic versus machine learning, it's not that you're blindly faithful that machine learning is going to do something amazing for you. You're really putting it into production, measuring and seeing whether it really does better than your existing solution today. And it gets you to the point where you can treat it in a scientific way, and you can deploy in this way that lets you control the process of starting with machine learning. Of course, the last but not least, we want you to be able to get up and running quickly, even if you don't have a strong machine learning expertise. So we have a zero setup environment for data exploration that is resizable to a few different instance types. It has common tools like Anaconda, TensorFlow, MXNet pre-installed, so you can actually do some local development on that environment just to test out and see what things work on your data set. It has ENIs to your VPC, which allows you to connect to data sources within your VPC in a very secure fashion. And additionally, there's no servers to manage. We manage the servers. You're in this hosted environment. One of the risks that I've heard from customers is that having data hanging out on edge devices is a pretty big risk. I mean, if someone loses their laptop at an airport and they have critical customer data, if they have personal information, that's a big risk. Where if you have this development environment that's hosted in the cloud, the data never touches that person's laptop in any significant way. And in fact, one of the things that I've played with during the course of developing SageMaker was I tried to access it from an iPad. So there's no local storage, there's nothing on there, there's no processing, yet you can train your machine learning model because all you're doing is accessing this hosted service through a web page. So what does this look like? We've designed it with a modular architecture so that it can interoperate with your existing systems. We know this is not a case where you're going to lift and shift your entire thing over to SageMaker on day one. We want to make sure that you can use the pieces of it, play with the pieces of it that you can easily adopt, and you can incorporate it into your machine learning development environment as it makes sense. So if you look at past data, and you start out with past data and some notion of a training algorithm, the past data stays in S3, which is a good, secure environment in your data lake so that it's accessible to multiple applications and it's stored in a way that you can control the lifecycle. And you put that together with the training algorithm in your machine learning model training. And the next thing that we do is we actually produce this set of model artifacts. And one of the novel aspects of SageMaker is that we treat these model artifacts as if they're data. Early on when we talked about a managed service to one of our financial industry customers, they mentioned that the way they treat machine learning models is they treat them as data because they're derivative of data. It's possible to do things like model inversion attacks so that you can, in some ways, derive the data from which the model was derived in certain ways. So it's super important for customers to be able to treat these models as if they're data. In this case, we looked at it and we thought, well, if you actually treat them as if they're data, you actually have this combination of data and code that make up the model. It's not just these model artifacts, these derivative parameters that are data. You also have a set of code that you use in order to interpret these parameters. So by separating them, you can actually use these artifacts, you can actually use your existing data lifecycle policies on the model artifacts and treat them the same way that you treat data. And again, because of that, they go back into S3. The next thing you have is inference code, and you want to put that together with the model artifacts so that you can generate a model that can be used for useful purposes. So we put those together along with some helper code into essentially a model. So at this point, you can now consume it in your applications. You connect to it with your AWS SDK. We have standard SDK APIs that you can use in order to send data into the model and receive the inference back. After that, at some point, you'll have the ability to get ground truth in most applications, the real answer. And then that feeds back into your set of past data that you can then use to complete the cycle of training and continue again from the beginning. Last but not least, this is pay-as-you-go and inexpensive. So ML compute by the second, starting at 4 cents an hour. ML storage by the second, and we have a free trial to get started quickly with it. So the next thing, how do you get started? To start with, we have a set of notebook samples that you can use, all based on Jupyter notebooks. You start with creating this notebook instance, which is a hosted environment that has Jupyter and the other tools installed. And in order to make sure that it's running with the right set of permissions, you pass in an IAM role in the same way that you would use for other AWS services, and you create this notebook instance. Once you have this notebook instance created, you open it up, and Ironman at this, or SageMaker at this point, has already created the notebook instance. It's installed software on it, attached an ENI on it as you specify to your VPC, also an ENI for the outside world, and then it allows you to get started quickly. The next thing you see is that it has a set of sample notebooks installed for common types of machine learning problems that use the algorithms that we've provided. So the next thing that you can do once you have access to your data sources and access to these samples is, I show k-means MNIST because in some ways that's the hello world of machine learning, where you use a clustering algorithm on this handwritten digit data. You open it up and you say, this is the bucket where I want the results to be. And this is where my data exists. And once you take that data and you specify where you want the model artifacts to get stored, all you do is, in a single call, you specify the number of training instances, you specify the ML instance types, and there's a certain set of parameters that you might want to specify depending on the particular algorithm that you use. In this case, for k-means clustering, you would specify the number of clusters where it says k equals 10. So you go ahead and you do that, and then the next thing you do is you call fit. And that's really it. At this point, SageMaker spins up the cluster, deploys the code that's needed, and pulls the data in and generates that model. The next thing that you would want to do once you have that model generated is you'd want to deploy it into a production environment. And that's similarly simple. All you say is k-means.deploy, you specify the number of initial instances, and you specify the instance type. It'll auto-scale after that based on the parameters that you set for auto-scaling. And you now have a production-ready environment in which you can perform inferences. So you go ahead, again, with the AWS SDK or the high-level Python library that we've provided, you can go ahead and do these predictions. So let me actually show you what that looks like in practice. Oops, that's not the one. There we go. So this is the console for SageMaker. If you take a look, it's got the notebook instances, jobs, models, and endpoints. And let's go ahead and look at the notebook instances. I've pre-created a few notebook instances for use here. We can open it up. And we notice that we have a few sample notebooks. Let me kind of zoom in a little bit. So we have sample notebooks, and we have this notebook that I've created called Hello World. So we look at the first step. This is going to be machine learning results in 5 steps. The first step is you pass in the IAM role and the bucket that you want the model artifacts to be stored in. So let's go ahead and run that. The second thing, the set of data that we have is MNIST data, and we'll we'll pull that down and kind of look at one of the samples as a proxy for doing processing. In a more real application, in this case, that you would want to do your cleaning steps, some analysis of what the data is, kind of decide what your experimentation would be at this point before you proceed to the next step. But as a proxy for that, we're just going to look at it. This is a handwritten digit. It's a 3. So the next step, we'll just go ahead and kick off training and deployment. And we'll see that'll progress for a while. It takes maybe 10 minutes to get finished up. So at this point, it's time to give Monica our turn. Here you go. Yeah. Would you mind switching us back?
Great. Thank you very much. As Kumar mentioned, my name is Monica Sue, and I'm a data science manager at Intuit. The team is specifically focused on using AI and ML to detect and prevent fraud for Intuit products. And we've been piloting using Amazon SageMaker for our near real-time fraud detection use cases, and that's what I want to tell you about today. But first, I want to give you a little bit of context about Intuit itself so you understand where we're at today and why using Amazon SageMaker actually makes sense for us. Intuit, you might be familiar with Intuit's products. We really see it as a comprehensive ecosystem for consumer and small business finances. So TurboTax is a consumer product for filing your taxes, has over 30 million customers in the United States and Canada. QuickBooks is a small business software for managing invoices, customers, vendors, etc., with over 2 million customers globally. ProConnect is accountant software, and Mint is a consumer product for managing your own personal finances. Taken together, across our products, 20% of the US GDP actually flows through our products. So when you think about that, from the perspective of a data scientist, there's a ton of opportunity we have to leverage our data to actually improve the financial well-being of both consumers and small businesses. And to that end, our mission is actually just that, powering prosperity around the world. And so we'd like to leverage data and technology to help people make better financial decisions. And the result that we're looking for is to return money into the pockets of our customers, both consumers and small businesses, also making the whole process faster. We realize that people don't necessarily want to be spending their time on their taxes and their books, so we want to return their time back to them so they can spend their time doing things that they'd like to do. And then the last thing is actually giving people complete confidence that their taxes and books are done correctly. And we see data and data science playing a huge role in this mission. Actually, we'll just say one more thing about Intuit before getting back to fraud detection and SageMaker, which is to point out that Intuit is a 30-plus-year-old company. And so we've weathered a lot of technology shifts over the years. We started in the era of DOS. We shifted to Windows and to the web, and eventually to mobile and cloud. And actually looking forward, we're looking forward to leveraging AI and ML more and more in our products. We've actually been using AI and ML in our products for about 10 years, but we've significantly enhanced our resources and efforts in that area. Okay, so when it comes to AI and ML at Intuit today, we have 3 different focus areas. The first one is what we call smart products. This is where we'd like to leverage AI and ML to personalize our products, automate repetitive tasks that might be part of the managing your personal finances, and also look for ways that we can actually find ways for people to save money and make money in new ways. The second area of focus is fraud detection and prevention, and this is what I'm going to be focused on today because this is what my team works on and how we're leveraging SageMaker for this use case. And then the last area of focus is customer care and expert advice. So here we'd like to be able to deliver very personalized financial advice to our customers when they need it the most. Okay, so again, I'm going to focus now on our fraud detection use cases and how we're leveraging SageMaker for this use case. Just to give you a little bit of context about the types of fraud that we're up against in a product like TurboTax, for example, our two use cases for near real-time fraud detection are account takeover. So this is where a bad actor is attempting to gain access to an account that does not belong to him. And the second is identity theft. So this is where a bad actor is creating a TurboTax account, but using an identity and data that actually doesn't belong to him. So it's slightly different from account takeover, but both cases, very importantly, require near real-time fraud detection. Fraudsters are adaptive adversaries. They're constantly changing their tactics. They're a living, breathing thing. And so we need to not only develop models that detect fraud offline, but also deploy those models online so we can enable our products to make real-time decisions to block fraud in its tracks. So we actually have both of those use cases in production today. So you might be wondering why we'd like to pilot Amazon SageMaker for these use cases. And we really see the key benefits around flexibility for both model development and model deployment. And so these are three specific areas where we see a lot of benefit. And this is showing us the from where we are today to what we expect to have with Amazon SageMaker. The first point Kumar mentioned already, ad hoc setup and management of notebook environments. It's very painful to set up notebooking environments just so you can start to explore your data. We see with SageMaker notebooks, it's very easy to explore data. There's pre-configured environments with accessibility to all the tools that we already use today. So that's the first point. The second point, we currently have limited choices for model deployment. So it isn't quite the case he mentioned where you're developing models in R and then translating it to Java, but there is development work required at Intuit to actually deploy brand new models. And SageMaker is a lot different because it's really built around virtualization. What that means is you can virtually deploy any machine learning language, algorithm, and package. And this is a big value add for Intuit. The last point here is we're currently working in a private cloud hosted by Intuit. And what that means is we'll have a lot of competing compute resources. And that's for teams and models. And you don't want that. You want to be able to have flexibility. And we're really looking forward to the auto-scalability of model hosting with Amazon SageMaker. So this is a high-level diagram of how we're leveraging SageMaker for near real-time fraud detection. And so what is the point of this diagram? What are we trying to show? On the left-hand side, we have data. And then on the bottom, on the right-hand side, we need to provision a risk score to the client service. In this case, it's TurboTax. So we're trying to turn data into a risk score that we can give to the product so that it can make a decision about whether some transaction is fraudulent. So starting on the left-hand side, we have data. We're consuming data off of a live event stream and pulling it into a Spark application so that we can calculate features. Features are essentially the signals that we want to draw out of the data that allow us to build models to detect fraud. So this includes reading in the data, cleansing the data, and ultimately processing the data so we can pull those signals out of the data. We then need to make those signals available for both model training and model deployment. So we leverage a feature store. We then are leveraging Amazon SageMaker for both training and hosting. For training, we need to pull the signals from the feature store, which allows us to produce a model. And then we host that model with SageMaker, which makes it possible for us to serve up risk scores to the client service. Again, that's just TurboTax. I'll end with some testimonials from people at Intuit who are actually working on this pilot and working with SageMaker. The first point is about notebooks. Again, this point is really one I'd like to emphasize because our ad hoc setup of notebooks is quite painful today. I like the availability of pre-configured environments with support for all of the tools that I'm used to, Python, TensorFlow with GPU, et cetera. The second point is actually around the pilot itself. The issues have been resolved within a day through Amazon SageMaker support. So this is really important because when you're working with a new technology and you're running into issues, you're able to resolve them very quickly. And then the last point I also made, which is around virtualization. We really appreciate the flexibility to deploy really any machine learning language, package, or algorithm. And with that, I will pass it back to you for the rest of your demo.
Thanks. Thanks, Monica. So let's go ahead and switch back and see if we're done training and deployment. So one of the things that you'll notice as part of this process is that you also get the log output directly in the notebook. So not only can you see what how the training progressed and consume the results of the training in this environment, but you can also see extensive logging information about how the training progressed and consume that in various ways. So even if it failed for some reason, you would be able to get enough diagnostic information that you can understand what the failure is due to. So we'll go ahead and scroll through. In addition to the diagnostic log information being available here, it's also pushed to CloudWatch logs. So you can use whatever tools that you use in order to normally consume logs and process logs in exactly the same way that you would normally do. It looks like it's still creating that environment, so I'm gonna kind of pull a cooking show thing and just show you the results, what it would look like. So what we would see here is that you'd see these sets of clusters. And k-means isn't exactly the most ideal algorithm for digit recognition. So what you actually see here is not digit recognition per se, but you see these clusters of similar looking digits. So for instance, this cluster looks like it's twos that are written in a certain way, and this cluster looks like it's a mix of certain others. It's certainly possible to take that algorithm and improve on the results of that algorithm. For instance, if you ran it for a larger number of epochs instead of the 10 minutes that I tried to squeeze the demo into, you would actually come up with better results. Or if you decided instead, hey, you're actually going to use the primary label information that's on there and say, well, this information, you already understand that it's a 3, so you can use that training information as part of your model. So the nice part is all of these can be done within SageMaker. You can take the unsupervised algorithm, the unsupervised clustering algorithm that's k-means, and you can run it here. And then you can say, well, maybe I'm going to get a set of labeled data, and I can try and see if the labels help the results. And I can run a linear learner or some other supervised algorithm. And then you can say, well, you know what? I really need the results to be very, very accurate for this problem. So I'm going to try and use deep learning, and I'm going to try and use Gluon to try and figure out whether Gluon will help me get a better result at the end of it. So at the end of it, it provides you with that set of flexibility that you need in order to transition from business logic to stepping in with machine learning, to using more sophisticated machine learning, to finally to deep learning if that's what you want to do. And it also lets you have access to all of the resources that you need because of the AWS cloud. So the switching from I'm training on one instance to 2 instances in this case, to 10 instances, to 10 Volta-based instances for a massive amount of data is something that's as easy as changing parameters in an API call. And that's one of the things that we wanted to achieve with Amazon SageMaker, and we wanted to make it easy to progress through and to shrink that 6 to 18 months from that to a period of weeks or days or hours in certain cases. So we wanted to enable that for you. With that, I would actually like to kind of leave some time for questions. So we'll go ahead and transition into that. Go ahead.
In the example you gave, two questions actually. In the example you gave about converting the model from R to Java, like suppose you have to deploy that model into a closed environment, but not in AWS. Could you easily deploy, for example, this model in a Java environment without?
That's a great question. So the question was the example where we had that I talked about where that R model is translated into a Java environment. The question was, is it possible to take it from SageMaker and deploy it into a different environment? Is that right? Absolutely, and that's actually one of the other reasons why we separated out the data-dependent components from the data-independent components. The model artifacts that you have are the full parameter expression of what that model is. So as long as you have inference code on whatever platform you want, you can deploy it there. There have been customers that wanted to deploy it in browser in JavaScript. There are some customers that are looking to deploy it on IoT devices, and we're working really hard to enable that scenario as well, where you want to take those parameters and push it into a device. So Deep Lens, for instance, is one of those things that allows you to play with pushing those models to devices. It is absolutely designed for that case.
Okay. And Amazon provides the different languages, or is that something that we need to do?
So the question was, does Amazon provide those languages? In certain cases, yes. So in the case of Deep Lens deployment, yes, we'll have a runtime for Deep Lens. In other cases, you may have to actually write the code that does that. But our intent is to have sufficient documentation about both the algorithm as well as what's contained in that model artifact container or model artifact file or whatever you want to call it, that set of parameters. We want to make it so that it's easy for you to write the code for whatever environment you want. Because honestly, we can't scale to the extent that you guys can as AWS customers can collectively. So we don't think we know how to write the best inference on every platform. We do rely on you to be able to use that information and run with it. Go ahead.
So around the deployment, in cases where you have models that may need to have some sort of automated or manual review for the type of data and the usage of that data, is there a workflow or an API that can overlay the deployment to look into those processes?
The question is, for certain types of data that are controlled, is there a way to overlay a workflow on top of it, essentially? On top of the deployment itself? Not at this time. That is a very interesting idea, and it's something that we'll have to think about and figure out how to prioritize. But I suspect those kind of deployment cases will become more common in the future.
Some industries certainly limit you around the usage of the data, and you have to check that the data scientist didn't accidentally bring the data that shouldn't be used in the model.
Absolutely. So definitely, certain industries have a great deal of need for control around deployment and the data that was used in that. That's something we look at deployment to different targets and different ways that we can do deployment as an area that in some ways we say it's day one. This is really day one for us. We think that it's a good start, but it's certainly not the complete product that we would want to have in order to kind of serve your needs. Go ahead.
The kind of SageMaker Python APIs that you're showing, do those work? Are those tied to the SageMaker deployment environment, or would those work in other IPython deployment environments that you already have?
Great question. So the question was the SageMaker libraries, the Python libraries that I showed, do they work in other environments? And the answer is absolutely yes. They're in GitHub. You can download them. You can use them on your laptops. Yeah, they work. They work together with Bodo. So you would want to use Bodo in conjunction with the SageMaker libraries, but they're completely open sourced, and you can feel free to modify them and contribute back as you need. Go ahead.
Does SageMaker support versioning of models out of the box?
Does SageMaker support versioning of models out of the box? In some sense, yes. In some sense, that's an area that I really want your feedback on how we should do that in order to make it more useful. The model artifacts themselves end up in S3, and you could have versioning on the S3 buckets, but beyond that, we don't provide any particular support for model versioning. That's something that you could build a workflow around. We have tagging support as well, so tagging is another way that you could do it. If there are ways that we can do better at versioning, I would love to hear them, because I think it's a very astute question. I think that will be something that we need to figure out how to do better, and I'd like your feedback on that. Go ahead.
Will you be providing the specification for the model artifact files, so we can potentially write our own APIs or embedded?
Yes, so the question was, will we be providing a specification of the model artifact files? Yes, absolutely yes. We want to make sure, we don't want this to be a closed garden. We want it to be as open as we can possibly make it, and we want you to be able to take those and move them into other systems as you need. You should be able to write inference code on it. In fact, you should be able to also, if you want to train in your own environment and use SageMaker for just deployment, you should be able to do that too. So we also have specifications for the Docker containers that are used. We have specifications for the model artifacts as well. The idea is you use the pieces of it that make sense in your business, and only those. Go ahead.
You demoed reading and writing to S3. Can you read and write in Redshift without having to go through that intervening S3 step?
So the question was, we read and write to S3. Is it possible to read and write to Redshift without going through the intervening S3? Not at this time, but that's actually an interesting idea. And again, I'd like your feedback on how we should do that in order to make it more useful. Go ahead.
So just looking under the covers, what does deploy give you? What is it that the predictor, in a sense, is it a reference to a web service and endpoint? What is that actually?
Oh, so the question was, what is deployed? It's actually a model that's deployed behind a REST endpoint. The predictor itself is, so invoke endpoint is the name of the API, the AWS API. There's a specific client that you can use called SageMaker Runtime. You can incorporate it into your applications, call it from Lambda, all of that kind of thing. All of that works. Go ahead. Is there any limitations on the training data sizes? Not as far as we know. Essentially, we have tested with the biggest data sets that we could get our hands on. There's nothing particularly limiting on the data set itself. It really depends on how much compute you have and how much patience you have to run through that data. I mean, yeah. Essentially, it's as big as you can manage. It's not like other systems that really have limitations on training data, because when you're streaming data and you're essentially processing the data as it comes in, there's no particular limiting factor.
Sorry, follow-up question.
Go ahead.
So under the covers, is that EMR you're leveraging behind the scenes, or what is the engine behind
So the question was, under the covers, what is the engine that we're using? It is, I'm going to answer that a little bit vaguely. The answer is we leverage AWS technologies in whatever way we can. It's certainly a very ambitious product on our part, and we wanted to make sure that we're not reinventing anything that other AWS technologies have invented. Some of the things are pretty obvious. You can see that we use ECR, but essentially the things that we use, we leverage whatever we can. Go ahead.
I saw in your FAQ that you can't access the underlying infrastructure that SageMaker runs on. So my question is, for deployment, how much control do you have over that REST endpoint? Can you use a custom domain name? Can you do authentication for the people calling your API, et cetera?
The question was, so because you can't access the SageMaker instances directly, how much control do you have over the endpoint? You can use AWS authentication. You can use IAM authentication to authenticate calls to the endpoint. But beyond that, I think the question that I would ask is, do you really want to be able to access the underlying hardware? One of the things that we want to take on is the responsibility of kind of making sure that infrastructure is up and running, and it's continuing to function correctly. And in some ways, that's the beauty of the managed service.
Yeah, so it's not the infrastructure I want, but like the API REST endpoint. Could I say open that up in API gateway and make whatever changes I want to the endpoint? Or
so the question is, can you open it up in API gateway and make whatever changes you want to the endpoint? Yes, to a certain extent, because you can't deploy code to the instances backing that endpoint other than through SageMaker. You can through SageMaker though. So there's no particular limitations on the Docker container. I'm not, I didn't tell you this, but it doesn't need to be ML. It can be a set of business logic that you deploy to that endpoint, and it lets you autoscale that Docker container. So we don't do any particular validation on the code itself. There's nothing magic about ML code that we can detect that it's ML code. Essentially, it's a Docker container with a particular set of adhering to a particular set of specifications, and we'll make sure the infrastructure runs around that Docker container. Go ahead.
Do you have any intentions to expand the library of screening algorithms? So the 10 that you are launching with, that'd be part A, and part B is, do they incorporate any elements of smart feature selection? The traditional stepwise or forward or backward or anything to that extent?
That's a great question. The question was, are we planning on expanding the 10 algorithms that we have at launch, and does it incorporate smart feature selection? The answer to the first is yes, absolutely. This is just the first thing. There's no, we want that library of algorithms to be as wide as we can make it. We're not limiting to 10. 10 just seemed like a good number to launch with. There's no sanctity around 10. The second thing is we don't currently have plans for smart feature selection, although that's a very interesting idea. I actually would like to understand more about what you're looking for, perhaps after this. Go ahead.
You might code those up and...
Yes, so have we published documentation about how to bring your own algorithm to the platform? Yes, absolutely yes. Not only that, but we have an example of how you can bring scikit-learn to the platform. And I think we may actually have an example of how you can bring R to the platform. So we have I kind of glossed over it by saying we have examples. We have a pretty rich set of examples, and again, similar to the algorithms, it's our intention to make sure that this library of examples is as wide as we can manage it. We want to make sure that you're able to use again, whatever frameworks you want that are suited to your business problem. Go ahead.
I just tried to create a notebook on SageMaker, and I see that there is limitation on the number of the instance type, and in particular there is no P3.
Got it. So you tried to create a notebook instance, and you found that there's a limitation on the instance types, particularly no P3. This is actually one of the reasons that we designed it this way, and you're right, it doesn't have P3, is because we think the way that most people would want to use the notebooks is to call the training environment and treat that as your compute environment. So the place that we actually have P3 instances is in training and in hosting. Those are the places that we have P3 instances. The notebook in our ideal conception is like an environment where you can do little test problems. We expect that most people would use the T2 medium. If the T2 medium is not enough and you actually have a set of data where you would leverage GPUs, we also have P2X large. But the bulk of your compute, we expect you to naturally do that in training, which is where you can really spin up a distributed cluster and you have access to a lot more compute. The notebook environment itself is relatively limited. One more question, and I think I have to wrap up.
Is there a VPC integration that you can access notebooks from the private link or direct connect?
So the question was, is there VPC integration where you can access the notebooks through private link? There is VPC integration in the sense that you can actually access data in your VPC. You can specify a VPC and access your VPC from the notebook. But at the same time, if you want to limit to access to that from your VPC, that's not currently there, although I've heard that request before from other customers, and that's something that we're trying to figure out how to prioritize. So if that's something that's useful for you, maybe we could talk offline and I could understand what you're looking for exactly. Awesome, I'll stick around for questions, but thank you all very much for coming, and I look forward to hearing what you think about SageMaker.